Hi again. So today I'm going to talk about different ways of making audiovisuals, in particular how to use shaders in Max, or just actually to be completely clear, it's how to use shaders in with MIDI, using MIDI. I've been using Jitter for a long time, and Jitter is great for some things and to produce a certain kind of graphics. And is well integrated with all of the Max objects that we know. We can write audio buffers into matrices and use those matrices to do audio reactive stuff. We can do FFT operations and do graphics with that. And we can use the shapes, use Jitter to control positions and so on. But there are also some limitations to Jitter, which I learned as I was proceeding into my audiovisual experiments, I guess. And these limits are mainly that you're stuck with a limited amount of objects and of practices, pretty much. And that it runs mostly on the GPU because it's based on vertices rasterization. So it's a process that runs on the GPU and that can interfere with your audio work because it's pretty CPU intensive. It's not easily possible. I know there are some people that developed some technique to do offline rendering, but it's not something that really it's intuitive to do in Jitter. Also, if you're interested in doing like spherical videos or VR renderings, I think that's impossible in Jitter. So all of these things kind of made me start looking around for other options of doing audiovisuals. And Max is my main platform. I compose in Max, but also like I tend to save all of my stuff in a MIDI format usually, because despite all of the limits of MIDI, and I think we all know them, it is a pretty it is a format that we can use in many different platforms, and it's still alive. I mean, it's pretty amazing, and it works fine in certain cases. So I think MIDI is a good way to save your stuff. Either you want to do scores, like you want to turn them into scores, or audio, or what have you. And as it turns out, you can also turn MIDI into visuals, as I will explain. So I started using pixel shaders. Pixel shaders they run entirely on the GPU. They are also called fragment shaders. And it's pretty much just a way of rendering an image pixel by pixel, which has some implications when it comes to programming, because it's a sort of like a GPU programming, which is a little different from say programming with Python or doing a more classical sort of programming. But there are a lot of incredible resources for fragment shaders, and the main one being Shader Toy, which is, if you haven't check that site out, I would encourage everybody to do so, because there are so many amazing artists and that publish their work on Shader Toy. And the amazing thing is that you have your image and you also have your code right there, and you can use the code. It's usually under an MIT license, so you can use it with attribution, and so it's really open for you to just explore different techniques, and that opens up like an incredible amount of possibilities that we can use, especially if your interest is to do kind of abstract visuals. So what pixel shaders are not great at is to do like real life rendering of things, like where you want to be very realistic. Even though there are people that achieve amazing things in that kind of shader programming, but if you want to do abstract stuff, that's pretty incredible tool. The disadvantages of pixel shaders is that it's code. So if you're resistant to code, then it might not be like a super pleasant experience, at least at the beginning. I wasn't a programmer like when I came out of my graduate school or whatever, but I started teaching myself that for algorithmic composition, and then I eventually switched. I eventually used that skill also for visual programming, and so that's something that you have to kind of like accept as a thing. And then the fact that you can there is some math involved, some trigonometry, but it's not like it's not like graduate level stuff. It's like really undergraduate level stuff for the most part, and then you have to build everything from scratch. Meaning, if you want to render a sphere, then you have to have a function to render the sphere. You can't just grab an object like a grid shape in Jitter and have it done. But you're going to have also like a library, like a file with all of your functions and so on, like that kind of stuff. So in a way, it's not that different. Before I talk about Shader Boy, which is the thing that I helped develop, which is a tool to render shaders with MIDI, there is another option, which is using shaders in Jitter. So you can actually use the GCL slab and program shaders in Jitter, and that kind of helps you with the management of the performance of your computer, because GCL slab runs on the GPU, so you can still have the CPU is left alone, so you can do your audio stuff. So that kind of helps you with that, but there are some problems, meaning you still have problems doing offline rendering, doing like HD or 4K rendering would be very hard. Even if you have a very good computer, that will be not easy to do in real time, because you have to do things in real time pretty much. You can't do it offline. And that gets me to the object of my presentation, which is this program. It's called Shader Boy, is a play on words with Shader Toy, which is the main source for shaders on the internet, and it's again like a website that is worth checking out. And this program actually accepts MIDI inputs, and I want to just demonstrate. So I'm going to share my screen. Let me move the Zoom window out. No, wait. Share sound, share. Okay, you can see my screen, right?
Yes, we can. Yeah.
So Shader Boy runs on the terminal. So you have to have like your terminal open, but then what happens is you get this window, and that's the program running, like with it would be like a window in Jitter or something. And let me just something like that. So this is a shader I was just working on yesterday. So it's fresh out of the oven. And sorry, I need to, I just want to show what the MIDI texture looks like. So this is what the MIDI texture that's coming in looks like, which is kind of dull. But if I start sending in MIDI data, then you can see how there's something happening in this MIDI texture here, right? This is the sound. And if you do some work and you want to get something out of this data that's coming in as pixels, then let me rerun it. Oh, I need to zoom out. So this is like, I chose, like, this is an example that I was working on yesterday. I think it works well to demonstrate what I'm saying, because this is pretty abstract stuff. Like, it would be very hard to do it in an OpenGL environment with grid shapes and vertices. I don't know if you can see what I mean, but so this is pretty simple. This is something that I'm still working on, but this is more of a finished product that I did. And with this example, I wanted to show how I'm always trying to do a very tight connection between the sound and the visual, and each note in that complex rhythmic texture is actually one of those lights that is appearing, right? So, and I think for that, actually, MIDI is great because it allows you to really map. I don't have to do any FFT complex algorithm. I can just get the MIDI note and map that to a light, for instance. I don't know how much time I have. I would show another example, but maybe I'm out of time.
No, I think you can go a bit longer if you want. Yeah, it's fine.
Okay, okay. So I will show another example. So this is just a couple of pieces that I did with this program Shader Boy, and I render them in 4K. I can render them in 8K if I want, 8K, which is the maximum resolution available. I can render. I did a couple of videos in spherical videos, so you can experience them as VCR, as VR, not VCR. And you can move around and see the object floating around. That's a more complicated process, but it's possible, and I intend to do more of that. And you can see, for instance, the starfish-looking object with the tentacles. That's something that it's not that easy to do in an OpenGL Vertex based programming environment. One last thing I want to say is that this code that you make for these shaders is usable in other platforms too. It's kind of ubiquitous because it's GLSL can be easily translated into like a C-like language. It can be used in Unity, so you can use it with all sorts of APIs in different programming environments. So you can actually use your work that you did on something on other platforms. You're not stuck with this kind of obscure program that I just presented, because it's not an obscure program. This is just a porting program. So it's a It's just like a way to port this code with musical inputs. Yeah, so I think, I don't know if I had anything else to say, but oh yeah, so you can, I should put up the link to join. For now, there is just a Discord channel where we are interacting. I've been, I think, the first or one of the first users of this program, and I helped the developer with the development of this. It's just a small community right now, but a lot of visual programmers are joining in. I'm one of the few like musicians that started using this, but I want to have more people from the music world come in. And of course, you're going to have all sorts of different aesthetics, but you can still achieve a lot with this tool. And I'm available for I have some videos online on my YouTube channels that in which I explain how to do this. How to port this shaders with musical inputs. I also give private lessons for people that are interested in it. If you want to check more of my work and see the whole, like I just showed a few examples, but you can check the whole video on my YouTube channel, which I'll also post on the chat, I guess.
So I'm working on this sort of sequencing environment, and the idea, the genesis of this is I work quite a bit with hardware sequencers, particularly those from Electron, and I really like the kind of the sort of ergonomics, in a sense, of the way in which you can sort of become absorbed in that instrument, because everything's available to you. But there are limitations with them, particularly that they make a lot of decisions for you about sort of the musical structure, particularly this idea of kind of a pattern, which can be up to 64 steps in length. And it's hard to get beyond that limitation. And as you chain patterns together, you're kind of, it's enforcing this sort of grid-like nature upon the music. And then another really important thing, and I think this is true of many sequencing systems, is that it segregates musical data streams into their own lanes that cannot interact in any way. And so the ideas were, one, give myself more freedom to be able to work with timing that's sort of desynchronized within the same patch. And then lots of accessibility in terms of parameters, and then the ability for different streams of musical data to interact with one another. And the goal here is to build sort of slowly over time a system that becomes more and more kind of the center of the universe that I use for composition. So I spent a lot of time thinking about this. I'm about maybe a month into development on it. So I have a simple sort of proof of concept, and I'll do a quick demo and then have a few just prompts for anybody who wants to jump in and provide thoughts. So the system is essentially rooted in these clock devices that feed into series of other devices. And the basic structure, for example, in this patch, which is a very simple implementation, is a clock feeds into a loop, which is essentially a modulus. So this clock will just output an incrementing value. And then from that, you'll have this looping, in this case, 1 to 8 steps. And then that drives this simple Euclidean pattern generator that's capable of outputting either the step number from the left inlet here, or there's also a right inlet where it can output the trigger number. So it could go 1, 2, 3 for each of these activated trigs, or it could go 1, 2, or 1, 3, 6. And then in this case, I just have this make note that's just going to output a fixed MIDI note at the 57 MIDI note at 100 velocity and 100 milliseconds. So I'll just play that. I think the audio is cutting in and out a little bit, but I don't know why that's happening. And then moving on to the next tab here, a little bit more complexity. So here we have, I think it's ducking for my voice. We have basically the same patch in the beginning, and this is receiving that same clock. By the way, I'm using Jamoma, which I'll talk a little bit about, and I would love to hear people's thoughts on Jamoma because I'm finding it's great, but I know it hasn't been touched in quite a while. So, and I think it seems fine, but I'm curious what you all think. In this case, I'm basically just feeding these sort of sequence generators, one for MIDI notes and one for velocity. So we'll start that. And you could see what's happening here is we have this rotate device sitting in between the Euclidean generator and the notes and the velocity sequences. And what that's doing is actually shifting along these timelines, which note is being selected. And I have a little bit of an issue here that I just failed to resolve before I got this all prepped for you, which is that Jamoma is a little bit confused about which device is where. So this should be moving, but it isn't, the notes device. And then the final example here is just one additional layer of complexity. And I'll mute myself in a second and let you hear it. But what's basically happening here is the addition of this gate, which is has 4 outlets. And you can either set here in the UI where incoming signals should flow, or you can pass that dynamically from some other device. So in this case, I have another one of these sequence objects driving the gate. And when you see a step with the value 2 get triggered, it's going to send the incoming MIDI onto this retrigger device, which creates a bit of a like a halftime sort of pattern. And it has a velocity ramp where it'll take the incoming velocity, and over the course of the 4 retriggers that it's going to produce, it'll ramp down to a velocity of 1. So as I mentioned, I'm using Jamoma for all of this, and I'm finding that to be actually extremely useful just because it really makes it easy to develop these modules, and it enforces some sort of discipline upon me from a programming perspective. It keeps the form factor of these objects constrained so that it's easy to fit many of them within the screen. It prompts me to design modules that are specific and narrow in scope, and kind of enforces a practice of having, anything that you want to do is really built of multiple modules rather than a traditional sequencer where everything's sort of baked into one. And the reason that that's valuable is there's a lot more flexibility in that modular approach, because you could go, while these are simple examples, you could go a lot further, right? You could, simply this idea of a gate that's driven by another sequence can be taken quite far. And even the idea of actually clocks being driven by sequences. So when you have events happening in the patch, driving sort of a secondary clock that may run at any speed that it likes, that causes sort of causal events within the piece. And those things are really possible with this modular design. So those who know Jamoma will know this, but I'll just show briefly how this all works. So let's take this loop device as an example. So Jamoma uses this model view controller model. And so each of these have a file name, which is got the name of the module and then the word module. And you'll see within that there's two components. There's this model, which is essentially the core engine of the patch. So this is the actual patch. And then you can see all of these green objects are meant to designate ways in which you can interact with the patch from the outside. And there's a few objects. There's parameter, there's message, and return. And this actually ends up working a bit like pattern, or maybe a bit like the pattern system plus sends and receives. Returns are things that send data from the model to your viewer. Messages are the opposite, things that go from your viewer to the model. And then parameters allow for the bidirectional flow of information between the model and the viewer. And this B patcher here is the viewer. And you can see that this is a very simple patch, and it's simply addressing these parameters and messages and returns that exist within the model. So remote is basically the corollary to parameter. And anytime we have a value change, so I could change the value directly here in the UI, but even if I had multiple view objects controlling the same model, those UIs would stay in sync with one another because of this pretty smart connection between this remote object and the parameter object. The parameter also has a lot of really useful features, like the ability to do range bounding. It can also, you can specify the types, so it'll do some type conversion. There's a thing called data spaces that allows you to do things like say, oh, this value is a time value, like a BPM or a frequency or something. And then if you declare once you've designated the data space for a parameter, if you declare the unit of a value that you're passing into a remote object, it will actually convert it for you into the correct unit that you need on the output within the model. So, in a one where I had BPM, I just say, parameter BPM, type is, float, data space is time, and then unit is BPM. And then if I passed into a remote object, hertz, it would actually convert that for me, which is pretty nice. And those are obviously things that you could do in Max, but it's really nice to have those things handled within the protocol without having to do any extra patching to support it. The last thing that I'll mention on the Jamoma side of things is this queuing system, which works a bit like pattern and pattern storage, and has been working decently well. I think one of the things that like I said, I'm generally happy with this Jamoma decision. The one thing I think that I need to think through is whether to stick to use of this queue device as a way to store states or presets or however you want to put them across the entire patch, because one of the long-term goals here is to really interact pretty deeply with queuing as a way to handle the kind of the broader strokes of the composition. So, while you may be able to generate patterns using patches like this, being able to really change the entire state of this patch on the fly and schedule these events is definitely a goal for me. And you could see I was already starting to do some of those queue changes just to move through the demo here. And all I'm doing in these cases is just talking directly to that queue using this kind of OSC-like messaging protocol. But I have a couple of objects as well that allow me to interact with those queues. And in fact, if you just click this open button, you can see that it's just a pretty simple text file that works a little bit also like the queue list object in Max, if anybody's used that one. So that's about it. The things that I'm thinking about that I'm curious if anybody has thoughts on are, number one, on the timing side of things. I had done some experiments early on to work in the audio domain to do timing and kind of have the whole system work in the audio domain. And I was finding it to be just more complicated from a programming perspective. And I was finding that it was bogging the computer down. And I've had better results just working with Max objects that run in the scheduler. So I'm literally just generating, I think it's a Metro in here. It's generating bangs and it seems to be working well enough. I mean, it isn't sample accurate timing, but I think that's working okay for me. But curious to hear anybody's thoughts on sort of using timing the audio domain instead, and you know, tricks you may have used to optimize that if that's a better approach. And then anybody who has thoughts on Jamoma, I mean, I think it's okay, but I just worry, you know, you look at the GitHub and it hasn't been touched in several years. So if anybody has better solutions for sort of this handling of modules, I'd love to hear that, and any other thoughts you may have. Thanks.
Okay. Fantastic presentation. Anyone got any questions? Ping them in the chat. Phil, this looks cool. Are you planning to use your patch for live concerts?
Yeah, actually, I'm going to do a really simple one next month here in Los Angeles, just to sort of road test it. And then longer term, yeah, I think I'd really like to I think I kind of actually want to move pretty much away from these boxes, you know, electron boxes and stuff. Maybe not entirely, but I like the idea of this sort of being the center of the universe, or even the idea of saying, you know, you may have something like electron thing, and then you can just record MIDI into a buffer that's within this system, and then you can drive, you know, using like a seek object or something, a CQ object, I think it's called, and just you know, like play back that MIDI from the buffer rather than using the hardware.
And so what are you, where's the sequencer going in terms of sound source?
Oh, yeah, and in this case, it's just a MIDI out to a, in this case, a Nord drum 2, like drum module. But yeah, that's actually another thing is, so, you know, I made a conscious decision not to really do any audio processing or, you know, DSP synthesis or anything like that in Max for this. I'm trying to keep the scope narrow to just, this is really about the sequencing and kind of broadly composition, and then rely on devices that exist in, you know, in software or elsewhere, VSTs or whatever else, or hardware instruments to actually generate sound. And as a result, I really am working largely with MIDI. And early on, actually, I was also, at the same time that I was kind of experimenting with audio timing, I was working really on like 0 to 1 floating value or floating point ranges. And since then, I've moved basically to only using MIDI because I know that the receiving device is going to use MIDI. So it's like, you know, you're working in a 0 to 1 range and then you're converting to MIDI on the output. What's the point? You might as well just like accept the fact that the world counts from 0 to 127. I think sort of echoing what Michele said earlier, like MIDI is good enough and everything supports it. So,
well, it's been pretty solid for a very long time.
Yeah,
and probably will stay solid. So that's like, that's kind of the beauty of Max, is that you get to a point with it where you can overcome the limitations of other things by solving the solution in a Max patch. So if you buy a piece of equipment and you're like, oh, I really like it, but I wish it could do this, you can just quickly go and make it in Max. At least that's kind of what I've done.
Yeah, I'm copying a lot too. I mean, a lot of them, the modules I've built are just copies of things that already exist on the Octatrack. And that's actually been good because it's teaching me, it's helping me to really build the modularity in, because I understand that instrument well enough to go, okay, I can think of the function of the sequencer in stages, from the initial clock to this idea of loops. And sometimes those loops are like hierarchically nested, right? On the Octatrack, you have this idea of kind of the pattern length. And then you have these tracks, and those tracks can each be their own lengths. And the pattern length is sort of controlling everything. And if you change the pattern, all the tracks are going to reset to step 0 or step 1. And one of the things to try to get beyond here was that, right? Like sometimes you want to just have something that's looping on 7 steps, just continually loop on that weird kind of off kilter meter, while other things maybe are locked to something more conventional like a 4/4. But sort of thinking through like, all right, well, how is the design of this thing? And then how do you almost recreate that, but without the limitations, has been really helpful for me. So as an example, I'm not showing my screen, but there's that retrigger device. I mean, it's basically a copy of what already exists in the Electron machines.
Okay, there were a couple of other questions as well. Can you address Jamoma objects to a MIDI controller?
Yes. So the way to do it is it uses this OSC style protocol. So basically each model has a name, which is the file name, but then it also has a sort of like local name. So actually I'll share again just to be able to show it a little bit more clearly. So you can see here, like this is called comp_clock, or this is called, comp_ukel. And if we go here, we can actually see we're receiving from the comp_clock device, and we're just getting its position. So the MIDI mapping, I don't think there's a more kind of integrated method for Jamoma than just saying, all right, I'm going to take in MIDI and map, a controller to one of these OSC addresses. So that's I think how you would do that. There are significant advantages, I think, to this particularly because Jamoma handles pretty cleanly this idea of like, okay, I'm just sending a value to this parameter. It's going to update the UI for me in Max. It's also going to update the internal model. And then I can save that as a queue really easily. Like I've done patches in the past where there was a lot of patching that had to happen just to allow there to be a UI on the screen and a MIDI controller and a whole set of queues that all needed to stay in sync with one another. And this is pretty clean. So there's also like a couple of objects that allow you to sort of like explore the namespace. So sort of like send messages where it's just going to dump out like what are the names of all the parameters for a given object, but you can also see them pretty clearly by just clicking in the object, which is pretty nice. So a little bit, you could do the similar thing with sends and receives, but some of the extra features here do make it easier. You can also see the state of the module. And you can also create presets, which is pretty useful, specific to the module, which is separate from this idea of queues that control states across the entire patch that may contain multiple modules.
Okay.
And what else do we have?
There was another question. Can this be hosted in Max for Live, or does it have to run in a full external Max? Do you have any plans to put this into Max for Live so that you can send the MIDI out of Ableton? Perhaps
maybe.
That's the question.
Yeah, maybe. It's not in my plans at the moment. I think the one thing that I may do on the Max for Live front is have some Max for Live devices that sit in the chain that can receive data from this system and then map to parameters of devices in the Ableton chain. So for example, say I had a a wavetable, which actually has, oops, I put it on the master chain. That was a bad decision. Hold on. So I think Wavetable actually has pretty decent MIDI mapping built into itself. but many of the Ableton devices and some VSTs don't. So, you know, if you pass a CC in and you want to modulate like the, you know, the, whatever this is called, the, what do they call this?
I think that's the position, wavetable
Yeah,
position.
I think it's funny. They, on the Blofeld, they call it the pulse width, which is like totally not what it is. But, you know, I think you can, yeah, you can see that. You can do that easily here, but like a sampler object, for example, has like really sad limited options as far as MIDI mapping. So you need to have a device that basically sits in front of the chain that maps using the Ableton protocol to that parameter in the device, and then it's looking for an incoming CC or whatever, NRPN or whatever kind of value you want to send in from the outside world. So that's the main thing I'm probably going to do at some point on the Max for Live side. I don't think there's any reason why you couldn't host like one of these chains in a Max for Live track. So you could just like, you know, have an AMXD where you could like build one of these and then the MIDI output just flows into the chain. The reason I'm unlikely to build that myself is just because I'm probably still going to be opening up the device. I'm probably not going to instantiate each of these modules as Max for Live objects. And I like working within the Max environment, and also the ability to have the modules, like the ability to not have segregated tracks is very interesting to me creatively. But it wouldn't be that hard, honestly, to port some of these things over to Max for Live if that was what somebody wanted to do. And the whole thing is actually already up on GitHub. So if anybody wants to work on that, I'd be very open to having that discussion.
Okay, well, I think we'll
Any
wrap
other
it up there then.
questions?
Oh, yeah,
Cool.
no, yeah, any more? Yeah, anyone got any more questions? Feel free to, or if there's any in the chat.
Oh, this is a good question. Any ways to design the patch? Yes. So one of the nice things is because you have this OSC style messaging, you can build a UI that's specific to the performance, right? So you could build a very complex patch and then say, even with all of these blocks, and I've actually already implemented in many of them this little toggle. Actually, I'm not sharing my screen again, but a toggle basically that just disables the animation in the UI to save the CPU. So in that case, you might just disable, you know, still drop these blocks in and figure your whole patch out at home, disable the animation for the live set, and then have a very simple screen that's constrained to just the parameters you want to be able to work with in a live situation, so that you're not working with this massive thing. And that's totally possible with Jamoma. And that's another reason it's so nice to work with Jamoma, because even when you have the same data coming to the same parameters from multiple places, it handles that elegantly, and it's not gonna, you know, it's not gonna do unexpected things. Oh, that's a good point, Nick. Nick mentions that the code hasn't been ported to the new Apple chips. Oh, yeah. So that's definitely a consideration if I ever were to get a new computer, which I'm planning to do.
Yeah, me too. If anyone's on the new Apple chips, I'd really like to talk to you, because I want to. I don't trust Apple to tell me how good their computers are. I need someone else who's used one to tell me.
Yeah. Particularly the GPU stuff. Curious about that.
Yeah, me too. Yeah, yeah.